Right now, wherever you are, take a deep breath. Go ahead. Inhale deeply. What do you smell? Maybe the rich aroma of coffee. Maybe the faint metallic scent of rain on hot pavement. Maybe nothing you'd call pleasant, but still something is there. Here's a strange thought. That scent you're smelling doesn't actually exist anymore. You're not smelling now. You're smelling then a moment that's already gone. Your nose. It's not just detecting molecules. It's detecting time itself. I know that sounds impossible, but by the end of this video, you'll see that your sense of smell isn't just an invisible radar for odors. It's a living, breathing clock, one that's intimately connected to memory, survival, and even the quantum fabric of reality. Let's start with something simple. Imagine you're standing in your kitchen and someone makes popcorn in the next room. The smell doesn't hit you instantly. It drifts in slowly, building up until suddenly, boom, you're in popcorn heaven. That delay, that's time. Every scent molecule's journey is like a letter in the mail. It was sent at a precise moment. It traveled through a medium, the air. And only now you're reading it. This means every smell is essentially a time-stamped event. It's like looking at the stars. When you see starlight, you're not seeing it as it is now. You're seeing it as it was years, centuries, even millennia ago. With smell, the distances are shorter. But the principle is the same. You're experiencing the past. Take the smell of fresh bread. The moment those molecules leave the loaf, their journey begins, bouncing off air particles, mixing with other scents, until eventually, some of them collide with the inside of your nose. Inside your nasal cavity is one of nature's most sophisticated detection systems. You've got millions of olfactory receptor neurons, each genetically programmed to detect certain molecular structures. For decades, scientists believed in something called the lock and key model. The idea was simple. A molecule's shape matches a receptor, just like a key fits a lock. If it fits, you smell it. If it doesn't, you don't. Nice, tidy, and wrong, or at least incomplete. Here, why? Some molecules with completely different shapes smell almost identical. Others with nearly identical shapes smell totally different. Clearly, shape alone wasn't the whole story. Then came a provocative idea. The vibrational theory of smell, championed by biophysicist Luca Turin. According to this theory, your nose doesn't just detect shape. It also detects vibration, the specific frequency at which the atoms in a molecule jiggle. Imagine two bells shaped completely differently, but both tuned to the exact same note. When you ring them, your ear hears the same pitch. The vibrational theory says your nose might work in a similar way, smelling the pitch of a molecule's vibrations. Here, where things get wonderfully strange. In the quantum world, particles do things that sound like magic. One of those things is quantum tunneling, where an electron can pass through a barrier that, in classical physics, it shouldn't be able to cross. Turin's idea suggests that when a molecule binds to a receptor in your nose, electrons might tunnel through it. This tunneling could be sensitive to the molecule's vibrational frequency, essentially reading its song. And here's the kicker. Those vibrations happen on timescales of femtoseconds, quadrillionths of a second. If this theory is correct, your nose is measuring quantum events in real time. It's a biological instrument, fine-tuned enough to detect the tiniest time intervals in the universe, without you ever thinking about it. Let's go back to our bread example. When a loaf bakes, different scent molecules are released at different stages. First, ethanol from yeast fermentation, then aldehydes from browning crust, then caramelized sugars as the Maillard reaction works its magic. By the time you sniff that loaf, your brain is piecing together a layered timeline, like flipping through a photo album of the bread's life. Some molecules reached you seconds ago. Others left minutes ago. A few might have clung to fibers in the air, arriving much later. When you smell, you're not detecting a single moment. You're detecting an overlapping collage of moments, stitched together into a sensory experience. For animals, smelling time isn't a quirky science fact. It's life or death. Take the bloodhound. Its nose can follow a scent trail that's days old. Not because it's stronger than ours, but because it can detect the decay pattern of scent molecules. Fresh molecules have one chemical profile. Older ones have another. The bloodhound reads that difference like a clock face. A wolf tracking prey does something similar, sniffing the path and knowing. This trail is from 20 minutes ago. That one's from yesterday. Salmon use smell to return to the exact river they were born in, sometimes after years in the ocean. They follow a unique chemical signature, unchanged except for seasonal variations. These creatures are reading time, just not with numbers on a watch. Here, where the human brain gets involved. The olfactory bulb, the first stop for smell information, connects directly to the hippocampus. That's your brain's center for memory and time perception. This is why smells are so powerfully nostalgic. One whiff of sunscreen, and you're instantly 10 years old again. Building sandcastles. The scent isn't just a smell. It's a time capsule, a direct neural connection between now and a moment from your past. It's also why smell can feel more immersive than sight or sound. Your visual memories fade, but a smell can drag you right back into an old scene, complete with emotions you thought you forgotten. Scientists are starting to see smell as more than just a sense. It's a tool for measuring time. Chemical sensors can detect the breakdown rate of molecules, which could be used to tell how long food has been exposed to air, estimate when a crime scene was last disturbed, track the age of pollution in the atmosphere. Even in space, future missions might smell alien atmospheres, not just to find out what's in them, but to figure out when those molecules were created. Imagine landing on another planet and detecting methane that's only hours old. That might mean something out there is still alive. Every scent you encounter is a ghost, a messenger from the past, carried to you across a gap in time. It's proof that you're never really in the present. Reality arrives to you in delayed fragments, whether it's light from distant stars or a puff of perfume from across the room. Smell makes that delay personal. It's the past, delivered straight into your lungs, and in a poetic way. It means every breath you take is part physics, part memory, part magic. So the next time you take a deep breath, remember, you're not just smelling the world. You're smelling its history. You're measuring events in invisible seconds and minutes. You're reading molecular postcards from the past. And that, whether you're a human, a bloodhound, or a salmon on a long journey home, might just be the most underrated superpower you have. If this made you see or smell the world differently, share it with someone who loves science. And maybe, just maybe, you'll give them a whole new way to breathe in time.